Well, hi, and welcome to my shop here for what I'm pretty sure is, hey, day 2, kind of, second video. Anyway, this is actually a couple of days since the last bit of video you watched where I wanted to start testing the tubes and got all sidetracked on some tube tester issues. But that's all taken care of now. So I'm back on this radio. Did I say what the date is today? Today is actually January 16th, so maybe it's been a couple or 3 days. And I have a tube tester that I've recalibrated, had a calibration error in it. That's corrected. That one tube tester has allowed me to test this tube already. This is the replacement for the defective rectifier, and this turned out to be good. S5AR4, a direct replacement. In it goes, on it goes. But of course we're not going to start this radio up just yet. I have a bunch more tubes you have to test. So I'm going to use this opportunity to do some proof testing of my tube tester. I'm going to put the one I fixed back up here on the bench, and then I still have my other, one of my other go-to tube testers here. So I'm going to test every tube in 2 tube testers for comparison purposes, and that's the remaining tubes in this radio. Okay, let me get everything set up here. So I think I'll carry through with 1 or 2 tube tests here on video, then the rest of them I'll just do off video and see what they get. But the interesting tube to do would be this one. This is the output tube, 6F6. So let's make use of this guy. I think I can just find this on the roll chart. 6. Maybe not. 6F4. Holy smokes! There we are. I made it. 6F6. Boy, I can't get any further down on this roll chart. It's definitely 6F6. Yes, and I have a couple potential replacements here, I believe. 6F6. No, that's the rectifier. I'll put that over there. I have 1 potential replacement. I have many more though, I'm sure. So we'll set this up. So 6.3 volts. CGGG. So that's CGGG. This control doesn't matter. It only matters when you're doing an EM test, I believe. This first test will be a GM test. Oh, this roll chart is hard to read. It's on an angle. It's 26431. 26431. 0520. 0520. 2 zeros. The bias will be set to 1.7, and that's about it. Let's turn this on now. This guy's got 2 tubes in him, so we'll let him warm up. Let's see if I can get this just a wee bit better here. Yeah, wee bit. Okay, so we'll plug in our 6F6. Make sure we're at 6.3. Test, and off. Yeah, one of the things that makes this tube tester really great is it has these terminals here that you can bring out voltages that are being placed on the tube pins. And it has this system in it that I don't understand fully, where you can utilize, essentially it's a way of literally taking a clip lead underneath the underneath here and clipping some things together you wouldn't normally clip using this control, I believe. That's a terrible explanation, but I'm going to leave it at that. Okay, we're ready to do the shorts test. We should see the light come on 2 and 7. That's all. 2, 7. Ready for the test. Except now we check the bias on the tube. Should be 1.4. Is that right? Let's just make sure I'm not wrong. 1.7. I was wrong. So on the 10 volt scale, 1.7 is going to be somewhere up like this. Bias, please. More bias. More bias. 1.7. 10 scale 1. That's minus 1.7. Check the line. Ooh. What has happened? What happened to my line? Well, the meter should be going right up middle school. What happened? Well, I guess I'm proving something about this machine right now. This should be down at 0. Well, it's not very reassuring that the meter's not where it should be. What happened? What happened to you? I don't know. Oh my gosh, I don't know what's happened here. Well, let's carry on. So the test result for this tube, it should come up to 1650 on the 8K scale. How do you do 1650 on an 8,000 scale? You're way down here, 1.6. Well, about there. Da-da-da. Went the wrong way. What is going on with my tester? Well, it's definitely warming up. And we can test for current flow. Oh. No current flow. What has happened to my beastly machine here? Well, this is really disappointing. I mean, this was working yesterday. What could I have done to it? I didn't do anything to it. Okay, let's try another 6F6 because this one is definitely not getting us anywhere. Off. Test. 6F6. Now this is my replacement, potential replacement. One of them anyway. This came out of the radio not working. 2 tubes have come out of this radio not working. And check for current. Still not. Oh my gosh, what has happened to this? Line. Here we go. Nothing. What could have happened? Oh my gosh. So disappointing. Bias is still 1.7. Ready for a test? Went backwards. I have to test a good tube at this point because I think my tube tester is failing. Failing here. So I think this is a 6C4. Yeah. 6C4, there it is. .3 E G 40650 12000 whoops, wrong end of the knob. 12000. 4.8 volts on the bias. Shorts on 1, 3, 4, and 5. 6.3. I wonder what could have happened here. Shorts. It was 1, 3, 4, and 5. So So 1, 3, 4, 5, nothing, 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 nothing. Test. 4.8 on the bias. 4.8. I can't get there. Okay, on the 50 volt range. Now I can hardly read it. I can hardly get there. That's another problem. This isn't changing the scale here. Didn't change the voltage. Can't get there. Well, I think I'm gonna have to skip using this tube tester. I think it worked fine yesterday, but she's not working fine now. Son of a gun. Backwards. Well, that's the proof test. All I've proven is there's something more wrong in this tube tester. Son of a gun. Okay, not the end of the world. I have another tube tester. Oh, okay, so once again, I'll just try to complete one tube test. So this is the one that came out of the radio. 6F6, 6.3, 6F6. I made a mistake here. That's why I double check these things. 6F6 2 46H. It's so easy to let your eye slip off the line on these roll charts and read, at least for me, 27345. 3, 4, 5. I got this right now. Yeah, see, my eye slipped up to the line above, and I set this up incorrectly. 0610, that's correct. 34, that's correct. F. Okay, now we're ready. Even when I'm alone here, I double check these things. I double check the label on the tube, everything. How come? Do this long enough, you make all the mistakes. I don't want to make the mistakes anymore. Grid bias, is that correct? 46H, yeah. Okay, so we look for shorts in this tube tester. The meter will rise if there's a short. Rise way up. Not that little bit. Doesn't matter. Actually reads the resistance of the short in megohms. Nothing there. GM test. And we're looking for 830, which would be about here. About where my thumbnail was. So this is the tube out of the radio, and it's testing okay. I'm going to put it right back in. I'm going to test my other one here. I might as well find out what condition. This is my spare. I have a number of spares. Okay, I saw the pilot light flash, which means the heater's taking some current. Why don't we just check the line here. Just a touch low. Different tubes draw different amounts of current, and so the all voltage at which this is operating goes up and down a little bit as you put different tubes in. My other tube tester even tells you to check the line voltage setting after you adjust the bias on the tube. This one doesn't have a bias adjustment. It just is whatever. Well, it does, but you yeah, anyway, I won't talk anymore. That's enough. Shorts. Short on pin 1. So the resistance of this short is around 1 megohm. I don't think that's the best thing. Let's give it a test anyway. Well, it still tests good. It's just going back into my collection. I would never put these in a radio without retesting them. They go back in my collection. If they come back out before they go to use, they're going to get tested again. Okay, and you know what, why don't we just, because of the headaches this tube could cause, this is the rectifier tube, 5Z4, let me just be absolutely sure it's dead. Z4. There it is. 5. No signal, no bias. 06030. 06030. P070. P070. 25. E for the plate connection. Oh, so this one shows that you should expect a short. I believe it's on the 1 setting in this tube, and then there's 2 plates to test. But I think this tube is dead. 5. 06030. 06030. And P070. P070. I think I saw that dip. No shorts. P1. So in this case, there's a marking on the scale here, which you probably can't read, but it starts right where my finger is. It goes up, and it says rectifier's okay. That's what we're looking for. This is what we got last time. Nothing. It's definitely warming up, though. Okay, that's great. That's great. So I'm going to go on and test the remainder of the tubes here. And I feel sad about my other tube tester. What a shame. What happened? Okay, this is the 6F5, the grid cap. Checking for shorts. Nope. Testing expectation here is 980 or just about 1,000. That's right about there. Way over. Very good. That's the 6F5. Okay, so this is a 6F5 that's in here now. 6K5. 6. Jim, come on. 6K7. 6K7. What am I talking about? 6. And what did I set this up for? Let's find out. 6K7. 233L 17342 17342 060610. Looks like I set it up for the right tube. 43. Yeah. D. Very good. So this time this should come up over 1,000. What about shorts? Any shorts in there? Nope. Up over 1,000. Okay, which is right here. She's a good one. Oh, this is going really well. Great. Okay, this is the 6A8 tube. Signal level 1. 20L 27345. 27345. 4610. 4610. 32. Yep. C. Yep. We're ready to go. Any shorts in this tube? Nope. And this guy, now this tube tester, like this is a complicated tube, and this tube tester is testing the whole tube at once. Only one test. And the recheck point is 750, which is only about here. That's quite a ways above. So I think that would pass. We have another tube tester, might run 2 tests on this tube. Okay, so that's all the tubes tested. Only one was defective, the rectifier tube. That's probably the tube that ended this radio's operating life. Probably it failed, and that was when they, hey, the radio doesn't work anymore, and they stuck it on a shelf. It's been there all that time till now. That's my guess. Collecting dust. Okay, so the next thing I want to do is I actually want to try to start this radio up, but not by plugging it in the wall. I'm going to try to start it up by supplying shop power supply voltages to it. And the objective of this is to find out, does the speaker work? Do signals get all the way through the radio? I don't really care how well it works. I just want to know that if you do something to the antenna, you hear something on the speaker. That's about enough for me. So I'll get ready for all of that now. So I think what I want to do with this radio at this point is get rid of this power cord. I mean, the wire looks great up through here, but is anybody really comfortable plugging this kind of wire into a wall? I don't think so. Now, I notice the radio is actually made conveniently for doing this because the power cord comes in and ends up at two terminals. This one, which I'm just going to cut it off. I want to cut the terminal off though. And a fuse terminal down here. Make sure I cut only the wire I'm after. Okay, and then we're going to cut it free here. So that just eliminates any possibility of when I'm powering up the radio, and it's not really possible. Power coming out the cord. It's really not possible, but just gets rid of some wire too. And I have to change that, and you know, in the end, I have to change that cord anyway. Great. Now, what we want to identify is where we want to feed in the power, the high voltage. The first thing I'm going to do is bring up the radio on a high voltage. Where are we going to plug it in here? Just so typically you stick the negative onto the chassis. I'm going to look for the here's the capacitor. There's two of them. There's one here. There's one up in behind here. All these stiff, the wires coming out of the transformer here are completely stiff. You cannot move them at all. Do not move them at all. You crack them in here or something bad will happen for sure. So we have this. So I see a lot of soldering right to this piece here. Now that may look like soldering to the chassis, but it's not, because there's a cardboard insulator sitting up there. And this is no, this is metal. Well, we'll have to assume there's some way that they're keeping this from touching the edges of the hole that's in the chassis. So this is not grounded. That's a possible place to feed in power, but I'm not exactly sure what's going on there. Now the other one is right to the chassis. Funny, up on top it has like a boot at the bottom of the capacitor, but it definitely looks, well, maybe the case may not be part of the capacitor circuit. How am I ever going to see in there? X-ray vision. Okay, from a little bit of a different angle I can see what's going on. So I see two terminals. Chances are they are both positive terminals there. And the negative is the chassis, and that's exactly where I want to feed some power in. Now, this one's heading out in this bundle of wire. That's kind of odd. This one's going up this way, up into this tube here. This would be the rectifier tube. You have to look at the schematic here to get a little more certain about where to hook this up. I think I'm going to do that. Schematic time here. Okay, I'm just remembering things now. The schematic I have is a schematic for an American version of this radio. Same manufacturer, made in Chicago though. This radio was made in Belleville, Ontario. It has the same number, R146, as the American version, but it's not the same radio at all. It's actually quite different in the layout The American version has an additional front-end RF tube, which would make the American version of this radio much better than this one. So the schematic, I just don't think I can rely on it for much of anything. The radio's different enough. I had better sort it out by looking at the radio itself. So, just in doing that, as I'm chatting here, I see a great big high resistance, high wattage resistor right here. It looks great though. Just things that need to be noticed in the radio. So if we look at the two capacitors and where their wires go. So this one connects to the outside of the capacitor along with these other components. Why wouldn't I just hook up right there and on where this red wire goes, feed in my high voltage there? Why do I think this wouldn't be a good spot? So this will be the secondary wire coming up from the transformer here, meeting up with this capacitor. So this is the first capacitor past the transformer. Then, usually there's a line that runs from here to a resistor. Well, okay, so I could power up this and see what happens. I mean, nothing's going to happen until I heat the tubes up. I have to apply the tube heater. Tube heating power too. But first it's just high voltage on here, see what's going on with all the capacitors. Is there a short or anything like that here in the radio is really what I'm trying to achieve. Put a little voltage here and then poke around with a meter and see where it's going. See if it isn't making it all the way into the radio. That's really the easiest thing to do. I like easy. I'm going to do that. So we'll attach the negative down here, not to the chassis. Somebody's written 280 right down here in pencil. Okay, and the other side of the supply will go here. Holy jumper! So my power supply is not on yet. It's way up there. It's not switched on. There must have been a little bit of residual power in it. I heard it come out of the speaker. Or am I imagining things? Did I imagine that? Well, we won't know now, will we? I think I heard a little pop from the speaker there. Okay, so the first objective is apply a little bit of voltage. And we look at the meters on the power supply, which you can't see. And this is the current meter. This is the voltage meter. This is the one we want to watch. This should not go up. Turn that down. Put this on standby. Give it a moment to warm up. It is a power supply. It has a rectifier tube in it, filter capacitors, all that stuff. So this is going to answer the first question. Is there something seriously wrong that I've hooked up this power supply to? That's kind of the first question. Watching this. This, in a good radio, this should maybe pop up a little bit and then drift right back down. Maybe a little bit drift down as I crank up the voltage here. Let's see what happens. Nothing until they do that. So if there was a short, this would already be over and I'd be done the test, because we already have a little bit of voltage here. We can see this rise up a wee bit and settle back, so there's a capacitor being charged. We're up around 100 volts now. There's a tiny current flow here. Get it up around, say, 150. My imagination's running away with me. I think I can hear things coming out of the radio. So that's a very good result. Now, have we actually put voltage all through the radio? I'm going to turn this down to a little bit of a safer level. Say it'd be around 50 to 75 volts. And then we're going to go look for it in the back of the radio See if it's getting all the way through. I'm gonna use my indicating meter over here. Let's get rid of this cord. We don't want to put this on the chassis, we want to put it the same place at the same connection as the power supply, but I'm going to do it right up on the power supply, where I think it's just a little bit easier to do. I'm always prepared for a big bang when I do stuff like that. Yeah. It's PTSD from working in a shop like this so long. Okay, then the other lead. First we check, make sure the meter's working properly. We're on the 50 volt scale here, and we got roughly 50 volts on the radio. So that should throw that meter right over here. There she goes, right over. Now, question is that getting into the tubes? Making it should be following all the high voltage wiring and go through, you know, arrive at every tube. Every tube needs high voltage. So just looking in the back of the radio and spotting some red wires here. I see a red wire coming to this tube right here. There's the 50 right there. So it is. I did make this connection. It does go through the whole radio. Almost certainly every tube is going to have it on it. So I'm just spotting red wires and testing tubes where there's a red wire. No red wire on this one. I think. I don't know if we're gonna spot it here. I'm not too worried. I'm not too worried that the voltage is not getting all the way through the radio, even though I may not find it on one tube. Very little danger doing this with the power supply. Well, I don't see it showing up on this particular tube, but I'm not going to worry about it. What this means now is we can power this radio from the shop supply high voltage wise. Now we have to power it low voltage wise. I need some better clip leads for that. There's going to be a little bit of current involved. Oops. Hang on for a second. I got the wrong leads. Clip lead here. Oh, there it is here. What's it doing over here? Get so disorganized. So my shop supply up here can serve up 3 voltages. B plus, C minus, and 6.3 volts for heaters. We're going to use the 6.3 volt. So this will apply current to the heaters. It'll heat the tubes up, and with the other supply operating, the radio should work. If it's capable, it will work. Now, we need to find a good place to hook up heaters. So the best place is just find 2 heater pins on a tube and hook it up there, and it'll cast its way through the radio just fine. So I'm looking for a nice clear shot here. Like this one up here. So that is a 6K7, I believe. I just want to be absolutely sure. 6K7. 6K7, the heater pins are 2 and 7. Could have kind of guessed that. Guessing not good though. 2 and 7. So we come up here and we pick off 2, which goes to ground. It goes to the chassis ground. That's good. And 7. 7 would be 8, 7. 8, 7. That's not so easy. I think what I just did was I discharged the capacitors in here because my supply's on standby. You can see it up there. No voltage showing. I probably discharged the capacitors there through the... Okay, I won't say much more. I'm always ready for that. Always ready for a spark. I really should be able to connect it here without any trouble. And I see little sparks every time I do that. What's happening here? How can I be getting sparks off this? How can I get sparks off this? Tell me the standby switch doesn't turn off the 6.3 volts. Can that be the case? Can't go forward under these circumstances here. So I'm just going to connect the 6.3 volts to my meter here, AC. I'm going to find out what is going on. So this is 5 volts, 2.5 volts sitting here. What the heck for? What was that? Things are getting really strange in the shop here. Is that a remnant DC voltage? How can that be? I'm hooking up to the AC output, 6.3 volts, 4 amps possible. Okay, so I'm going to turn the supply back on. And we should see 6.3 volts AC here, 15 volt scale, 6.3. I'm getting frustrated. We're on a 15 volt scale. 3. Yeah, this has not been a good day here. I don't quite understand why it's doing that. Why are you doing that? So if you try to measure an AC voltage with a DC meter, often what you see is the meter movement will pop up. Just pop a little bit, pop, and go back to 0. So you get a little hint when you're using a DC meter and you're actually hitting AC with it. Now we're back on AC. What is going on? Bad clip lead? Well, we think it would be 0. and it would jump all over the place. These are my better clip leads. Pull it out. Oh my gosh. I pulled the wire right out of there. Now, I mean, there is another ground coming down. Oh my gosh. This is really just completely unexpected. Okay, putting the black one back into there's issues around the grounding of these terminals and the way they're connected inside the device and internal connections and that. There's a little map here that shows them to you. Looks like it's telling me. Ooh, what happened there? This is really, oh, you can't even see it. This meter is behaving very oddly. Everything's going downhill here. So, normally, let me just flip this to, watch when it comes back. What's this? Ding, 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 ding. That's not normal. Watch again. Didn't really do it that time. Let's leave it down for a bit. Yeah, it didn't really do it again. What? 5-volt scale. It's supposed to be 6.3 volts here. It's exactly half. Exactly half. Now I've used this to power tubes and it's worked before. What is, here I am just totally going down the rabbit hole here very quickly. Actually, I found a rabbit hole in the rabbit hole and I crawled into that. Oh my gosh. Where's my multimeter here? See, when you read instructions on things, they say do this, do that, do this, do that, but they never say, if you get this totally unexpected result, then here's the 5 things you should do after that. No. So you read the instructions, do this, do that, you do this, you get a weird result. It's game over. Oh my gosh, look at that. So we are looking for an AC voltage here. 20 volts AC, 20 volt AC scale. Show me 6.3. 673. Decimal point isn't showing up all the time. So this is telling me everything's fine. What's going on with my other meter? Now I'm going to put this on standby. Look at that. It remains. Okay, lessons learned. I kind of thought standby meant standby. It means standby for the high voltage part of the supply only. Okay, didn't know that. Now I know that. Gotta learn that lesson. Paid a price to learn that lesson. As I mentioned in other videos, there's always a cost to education, no matter how you do it. Somebody's going to pay some price. And the price could be their time. After all, time is the real money, isn't it? Okay, now, so I can put the power on here, but I got to turn this guy right off if I don't want current flowing right away. It's scaring me and making me think dumb things. Okay, so we'll put the negative back on here. Now, positive, I can kind of jam it in there. Everything's switched off right now. big clip lead. It's just too close to make a short there. It's too close. Great big fat clip lead. Gotta find another spot to apply the there it is, right there. There's a spot right there. Yeah, kind of a gray, kind of an orangey, dirty yellow wire running between all the tube heaters. I've spotted it. Okay, so what should happen now is I turn on the power supply to standby. Current begins to flow to heat these tubes. You can make an observation, find out that that's true. Then after that, I bring up the B+. I need a meter on the B+, because I want to keep an eye on it. I don't trust the meter up on the supply itself. I'd rather know what's going on right down in here. So to do that, put this one, hold it right there. Don't put this one. We're not going to use this one. This guy is connected to hydro ground through the meter. I'm about to put it in a non-chassis position. I already have stuff hooked up to chassis type connections. That sounds to me like a recipe for disaster. So I'm going to use this ungrounded independent meter. And we'll just clip it in. And avoid another surprise. So now we want to read B+ to where exactly? To the chassis? Kind of read it to a cathode, but that's not the best way either. Chassis will do. Chassis will do for now. To the chassis. And then the positive. Pick off another positive place up here, which is probably a better way because it's kind of in the radio then. So if we take the 6K7 and ask the 6K7 which pin is the plate? 6K JJK7 which pin is the plate? 3. Pin 3 is the plate. 1, 2, 3. There's a nice red wire coming to it. So we now have a voltmeter monitoring the high voltage that's going to come at it here. How high should we go? So this is a transformer radio. Probably has a fairly high B+ of a couple hundred volts anyway, but we don't need to go that high. Now before we do this, what's going on with the speaker there? So a little bit of a difficulty with this technique is the speaker itself, the field coil is not going to be energized by this technique. So what we need to do is pick off the voice coil signal. So the output transformer is right here. So what's coming up here is a combination of a heavy DC current to run this electromagnet and another high voltage DC supply that's passing through this transformer on these wires, on some of these wires, on so what they've done here, I was going a little berserk, they've made 2 splices under this tape. There's 2 independent splices taped together here. So it looks like one splice. I'm sure it's 2. So one voice coil connection's here, and the other, I think, is right here. Let me look up in there. So I'm looking up inside the speaker now to see the voice coil connections. There they are. All I gotta do is just hook up to these 2. What? Hook up what to those 2? I need to take the signal from these 2 and hook it up to my spare speaker. That's right. That's right. Okay. The speaker may still make some sound, but there's a good chance it won't make any sound at all. This one should do the trick with a stupidly long cord. How many of us do the tap thing before we clip on? Us who do this kind of stuff. Okay, the overall objective of this is to basically prove out the major components of the radio at this point. So we want to hear something come out of the speaker, and want to touch the antenna and hear or something come out of the speaker, and if it actually works as a radio, bonus. But we just want to hear stuff. I've forgotten to put the grid caps on the tubes. I just realized. I'm not going to get too far with these all off. So these tubes have a three I don't want to say letter, but you can call it a 3-letter designation or a 3-digit designation, like a 6K7. This terminal was moved to the base of the tube, and from then on the tubes were called single-ended because they only worked on one end. They didn't work on both ends anymore. Single-ended, and the S that denotes that was stuck into the name. So 6K7 became 6SK7, and this disappeared, and it's down here now, down underneath. Little tube lesson there. And the numbering of tubes is completely irrational and irrational at the same time. So this is the high voltage lead, which our supply is switched entirely off. So I'm going to leave it not up there for now. This is our big DC meter. I'm going to stick it over here. Now, every tube in this radio is a metal tube at this point. There's a 6H6 in there I didn't test, but we're going to carry on. I'm not going to worry about it just now. 6H6, I think they're pretty simple, reliable tubes. Oh, okay, controls on this radio. I should rotate the whole thing around this way now. Good luck on that. Can't do that. Can't do that because of these wires. Okay, this way. Gotta know which one's the volume control. Probably this one. This is the on-off. It snapped it, you just see dust fall out of it. And this is probably tone. Maybe not though. So I'm going to turn this down. Turn this guy down. Right, that's down. Switch on or off doesn't matter. Okay, I think we're ready to go to the next step. We don't know what band the radio's on. What does it matter? Doesn't really matter. Band switch probably hard to operate. No, it's not. How many bands are there? There are. Boo! Hard to tell. Looks like 4. Four bander. 4 bander. 1. It's a little hard to do. A little painful. 2, 3. How do you get 4 bands in 3 settings? Because I'm just too feeble to turn this further. I don't think so. I mean, I'm going to put a tool on it. Put it on this way so I don't have quite so much power. 1, 2, that's it. There's only, how does that work? So it must be the scale, there's 4 scales, but there must be only 3 bands. Yeah, it's not going anywhere. I think we're ready. So first we'll apply the AC. You know what I can do here? I can do something. I can do something, provided I find this meter. 2 amps AC. We can look at the current going to the heaters. I just pick a good wire to clip this on. That'll give us a current reading of the heater current. Okay, so I'm going to flip the power supply on to standby. This guy should show current going into the heaters. Step 1. More than 2 amps. 2.2, 2.1. My supply is good for 4 amps, so this is easy on it. Now, does that make sense? There's 1, 2, 3, 4, 5. Wait a minute. I've been counting the number of tubes wrong. I've been missing the little 6H6. So this is 1, 2, 3, 4, 5, 6 tubes. That's the same as that schematic. But yeah, I don't think it's the same as that other radio though. Okay, let's carry on. Tubes will be heated up by now, carrying 2 amps, 6 tubes, carrying 6 tubes, carrying 2 amps. That's actually 6. 300 milliamps per tube, just as a guess, or say a quarter amp per tube. So 4 amp and a half. Well, it's in the range. It's in the range. So now we're going to bring up the B plus slowly. The result of that is we should start hearing sound come out of the speaker at some point in this affair. Get up around 100 volts, it should be enough to operate the radio. So we're going to flip on the high voltage here. And we have to attach it to the radio first. Flip it back off. I expected that meter to pop just a little bit when I flipped it on. Get back to everything set. All ready here. This shouldn't change. There, a little bit of voltage. That's kind of what I was expecting. Flip it on, it'll jump. Blink. Jump negative. Now we're going to start cranking it up. Everybody quiet while we try to listen for sound from here. And watch this meter. Eyes on the meter, ears on the speaker. So that should be enough. I think so. Let's hold it here. I don't hear anything. I'm going to listen for a hiss in the speaker. The radio comes to life when I got my ear pressed up on this. So I hear absolutely nothing from that. Nothing. No hiss, no hum, no nothing. So something has not worked out here. Or there's something more with the radio we don't realize. Wow, these are just so persistently close. There. Well, we can try making some sound come out. So I know the output tube is sitting right here. That's the output tube area. Oh, I didn't turn the volume up. Hang on a sec here. Okay, so I heard sounds. That's good. That's a start. Now, I don't hear anything quite like a radio, but there's no antenna. No antenna can make a radio totally quiet. A weak radio going to be stone quiet. Just because there's nothing for it to chew on. Let's give it something to chew on here. This is basically an antenna to nowhere. And weren't we suspicious that the actual, this is the ground connection. It's supposed to be here. Nothing's coming out. Maybe this is volume. It's up full. Oh, hear it? Now that could be the same here. So that didn't count. We were going to try to stick a signal, not an antenna signal, stick a screwdriver, hummy signal in on the output tube, looking for what might be the grid. Let's find out what it is here. And poke around unnecessarily. 6F6, EFG, 6F6, the plate, or the grid. Let's go for the grid. The grid is 5. The grid is 5. So we're doing a little signal injection, a little bit of noise on the screwdriver shank here. That's the idea. Number 5, we go 5. 1, 2, 3, 4. This looks like 5 here. Well, it's making some noise. Okay, just double checking everything to make sure. Now we've got 25 milliamps flowing in on that power supply. Now let's think about the tube currents. These are all small tubes. Tube current might be 10 milliamps times 5, 50 milliamps. I only have 25 milliamps. Well, maybe I'm overestimating the tube currents. I guess powering 5 tubes. 10 milliamps a tube. The output tube should be 30 milliamps alone. So it sounds like we have not got tube conduction all the way through this radio. How about we tap it? Now tapping grids is easy in this thing because they're all produced on the top of the tubes. Those grid caps. So we'll now do signal injection with a screwdriver. Listen quietly. That's pretty good. I put my finger on it. Now, this is not terribly dangerous what I'm going to do, but I'm still fully insulated from the floor I'm standing on, and my spare hand, you can't see it, can you? It's hidden. Ooh. Well, that was a little odd. What's odd here is it made it seem like it was a bad connection. Depends exactly what you touch on that. And then the other tube is this one. And my finger on it. Not a lot of sound coming through. Okay, can we conclude anything from that? We can't know that the speaker is good, the big one, but we know that sound is being delivered to it. It's tempting at this point to put the rectifier tube in and power it up. That would power up that speaker. We need to find out if the speaker works. So we can do this also in a careful, progressive way. So I think I've proven it's safe enough to try with its own power supply, even though nothing's been changed capacitor-wise. That's my thinking. Okay, let's do that. So I'm going to shut off this supply and remove everything out of here. I could leave a voltmeter connected. Because it's just not wise to have reams of wire all over your bench when you don't need it. Get rid of all this. The reason for that is if something goes wrong and you've got a pile of mess on your bench, you probably, first you're not going to react right because you're going to react, suddenly. Okay, so we'll keep this on. We'll keep this meter on where it is. And if you have to grab something, do something, and your eye is too busy with all the junk on your bench, and you got to dig for stuff. You can't be digging. If you're in a panic, you'll start throwing things out of the way. Who knows what? So it's just panics do happen when you do this kind of work. So I have the tested rectifier tube replacement here, 5AR4. In you go. Just check and make sure every tube got warm. That's good. Oh, now I don't have a power cord on there anymore. Is now the time to change the power cord? Or should we do something temporary? I can actually do something temporary here because there are terminals in the radio. I take my really ugly cheater cord here. Okay, this is just a short-term test. And we're going to go right where the power was. There. Get on there. Okay, that's good and solid. Likewise for this one. God, what was that? You can be scared by anything. Little block of wood falling. That's good. That's good. Okay, so this is going to go into my somewhat overdone control deal here. Going in here. I'm going to feed the power to here through a dim bulb light from this controlled variable supply. Slowly raise it up. We're going to watch the current flow here, the B plus over here. That's going to develop by the radio itself. And it's probably going to go well over 200, but we may not let it get there. Bring it up slowly. The problem with doing that is the tube heaters also come up slowly. So if you could have the heaters on full, that'd be a lot better, but we can't. So we're going to bring the whole thing up slowly. So it's going to have to get up quite a ways before we have any chance of this thing actually operating. The volumes are up. I'm going to turn them down, or whatever they are. It's also possible maybe a voltage on the chassis here. The power's getting to this radio through an isolation transformer hidden through this. And although this produces a ground here, the ground on this cord is lost by the time you get here. There's no ground. There's no ground here. So it's completely isolated. If I hook up test equipment, the isolation can go away. So, but I've hooked up this meter, which is a separate meter. That's it. Okay, man, here we go. So again, I'm forcing the power through this light, just as an added safety feature. The fuse is in. So I put a proper 1 amp fuse in here. So we just start raising up the voltage here. Okay, something funny happened. Because I don't have headphones on. I'm not listening to the actual recorded sound. We got up a certain height, and then my level meter here, this is my overload meter, it's supposed to tell me when I'm talking too loud. I'm right up. So you heard something crazy there. What was it? I wouldn't expect any sound in what? Yeah, what? Let's try it again. I got my headphones on this time. I heard it. That's interesting. I would almost suggest there is something was breaking down or shorting out in here. I didn't look to see this. So I've turned it down again. The tubes will have warmed up a bit and just gone right down again. The rectifier tube may not be rectifying anything. Get nothing on this meter till we get things up pretty high. What was that sound? It was pretty distinct. Could have been a poor connection. Could have been a poor connection. Okay, let's try that. We'll turn this up a bit. And we'll wiggle these. I can definitely hear it. Now, I'm going to make a change to my own sound. So my problem up until this moment is I've been unable to monitor video audio properly. I cannot tell the relative volume of my own voice versus anything else that's going on here until I do this. Okay, now I hear my voice loud and clear. So, in fact, I gotta turn this down a bit or I'm gonna blow my ears off. Okay, now up on the voltage. Oh, it's still up. Let's go up higher. Starting to make voltage here. The rectifier tube has got enough going on. Oh, what's that? What do we hear? Taking my headphones off. She's a humming. Now I gotta get this speaker out of the picture here. I shouldn't have left it on. Huh. Well, that's a really bad sign now. Why is this one not humming? That's what's there. How come you're not humming? Now the field coil must be conducting. Not much of a magnet here. So we're still pretty low on everything. Oh, you know what we're really low on? There's no B plus in the radio. How do we get 128? Oh, right, Jim. Calm yourself down. I looked up at my power supply and thought, oh, the power supply is not supplying B plus. Right, it's not. It's internal. Come on. Must be getting towards the end of my shop period here. No sound from there, but not sure why. But there is sound available. Let's stick with that. Very distinct hum. And of course, that's because I haven't done any work in this radio yet. We're supplying it with all of 56 volts. You just think it would take a very small current in there to get this thing going a little bit so we could hear a hum. Dead quiet. And if the speaker doesn't work, it's a big problem. You know, big problem here. I don't think there's a problem in the radio. I can get my all the way through it. Okay, power off here. We must find out if the speaker is working or not. That's going to be it for today. Just checking the speaker will be it for today. So what I have to do is I have to throw some current through the field coil, and let me just make things a little safer here before I forget. Get this thing out of here. I'm going to want to feed a few things here. Probably going to want to change these wires. Hey, these are nice. They're nice and flexible. Wow, these are really flexible. Somebody did quite the bang-up job of soldering these wires together. I'm tempted to cut these away now. How can we tell which is the field coil? Well, I can see it. I can see that this wire goes in the field coil. And then it's got to come out on one of these other two. And because he's tied the splices together here, we can't really see it. Let's get this out of here. Maybe there's a problem right in here. Maybe he did something stupid. Because wow, is that ever... Your bad cameramanship. What's under here? Did he put this into one big blob? Oh my gosh, did he really? No. No, it's two. It's two spicy. He did what I do. He did exactly what I do. Okay, let's might as well take this off because it was hanging in there. So this was done by somebody who knows how to put this tape on. That's for sure. And by that I mean when you apply this kind of tape, you stretch it a bit. 10%, 15%. Some of this tape you can stretch out almost 50%. When you stick it on, and it pulls itself together. You just put it on loose without putting stretch. So I can now see quite clearly that these two are the field coil. What we're going to do is we're going to interrupt one of those wires right through the middle. Something went flying. Oh, it's just that. I'm going to force a DC voltage in through here, a current. I'm going to use my high voltage shop supply to do it. So I can control the output, so I can control the current flow, and I had a meter to read it with. That'll turn on the electromagnet in the speaker, and then we just have to stick a sound signal into the speaker. Get ready. Polarity won't matter. Pretty sure polarity doesn't matter. So the other way in is this one. Now, hook up the output from here. This guy's very annoying. He has little dirty switch problems, so we'll get him going on the known speaker first. He's already going. Perfect. Okay. Now we're going to feed that signal, which is enough to make that little speaker work. It should be enough to make the bigger speaker work too. Feed that into what has to be the ground wires straight. This has to be, oh, not the field coil. Whoa, 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 no, 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 no. We're going to put this into the field coil. And not look at that, voice coil. Jim, speak English. It's all English. You can hear it. I didn't even have any DC in there. So, okay, so this is proving the speaker's good, I think. But let's put some DC up, a little stronger signal there. And now we're going to stick some DC into it. Never done this before. Typically those coils are a couple thousand ohms, so I don't think there's much of a big risk here. I'll let the tubes warm up in there. But just the fact that it can be heard already. You know, there could be, look at all this metal. There could be residual magnetism in here. A little bit. I can feel a little bit. And that's probably enough for the voice coil to move. What I would expect is it's going to get a little louder as I do this. So I can watch the current flow, make sure it's not too much. Yep, getting louder. That's really all we need to do, but what we'll do, we'll stick this up a little bit. That's 30 milliamps. Probably much more goes through there normally. And we'll just frequency response this thing. I'll just crank the frequency up and down. Let's go down. Down is always more interesting. Okay, so I kind of disappear from my hearing here. We'll crank up the output. Not getting very loud. It's there though. Okay, we'll go real low. A little more of everything. Sounds like it's moaning. Can you hear it? It doesn't sound right. Okay, we'll go for the high stuff. Up to 10,000 I can hear it easy. No problem in the high stuff, of course. So that low sound, the low, I don't know what to call it, distortion or what, maybe it's because I'm not powering this in the normal way. But there are holes in the speaker. I can see one right here. And I think I saw some cracks when I looked at it earlier. Wouldn't think they would cause the kind of sound I heard. Just some subtle distortion. But the bottom line is it's working. That's the primary thing. So we've pretty much proven the whole radio is capable of working. Now it's just a matter of fixing up the small parts in it and tuning it up. It should work. That's great. Well, thanks a lot for watching. And tomorrow I will get to doing the capacitors in the radio, and we'll see if we can really make it work. Hey, turn off the high voltage before you forget. Yeah, thanks a lot for watching, and see you tomorrow.